Hello class, this will be my video presentation for Projectile Motion project in MATLAB. I named my function target, as we'll see the reason for that here as I attempt to show it off. Well, let's just go start with help first, help target. It brings up obviously the credits. Jacob Hickman is my name. It's a target practice game, and I've established that we want to hit this target that we'll create within 3 shots. The inputs here are the target X and Y positions, and then our initial X and Y positions. And that will get the program off and running. If the initial positions X and Y are avoided, it's just going to set it at the 0, 0 mark, and we can shoot from there. So let's play the game. Target, let's set a target at 500 meters away and 50 meters high. I'm going to just assume that I'm at 0 and 0. And there it establishes a graph with a target icon there. And it prompts me for a first attempt at my launch angle. So for this first launch, let's try a 6-degree attempt at 250 meters per second. We'll see it plot there. You can see the explosion from when the cannon shot was fired, and when it hit the ground, it plots the high point at 35 meters, and that happens at about 660 meters away from the initial spot. Obviously I need to increase my angle and probably my velocity, so let's try a 7 with a 300 for the second attempt. And there it changes color, still plots it. If you looked really closely, I have the divisions and the speed at which it's calculating this, the pauses between, are related exactly to the velocity. So it should, if you were to plot two sequentially, you could tell that the first one was plotted a little slower than the second one because it's moving slower. But the divisions are also dependent on how long the flight is, as I did not want to see too many dots for a short flight and too few dots for a long flight. So it varies. But we still missed our target. I have it set to a range of 2%, either high or low, when the X and Y position of the shot nears the target. It needs to hit within 2%. So let's try it one more time at like an angle of 7.2 degrees, and I liked that 300 meters per second, so let's try that. And boom, we hit our target. It still will give you the reach that it would have hit, 72 feet, and at 1,001 meters away from the initial position. So let's take a look at some of the coding. Here we have the code, the margins for using, for ignoring our initial positions if we don't want to put those in. This is going to plot the target initially, and then we get into our first attempt at hitting the target. It's fairly standard projectile motion equations here. That's how we divide the divisions up based on the time of flight. And this is our if statements for if the projectile is within 2% of the target tolerance high and less than the 2% of the target tolerance low. And if it doesn't hit that, I mean, if it hits the target, it'll break and cease firing. As we can see here, it did not complete the projectile. But if it doesn't hit within that target, it's going to keep going, and it will plot the once y of k equals 0, it will plot the cloud of smoke there that we see at the bottom, these white clouds. And then that's just repeated for the second and third attempt. Hopefully we can hit it, and I'd like to challenge you to try a couple shots. If you wanted to play with it one more time, we can change our target position to, say, 320 meters high. There it is. Let's try 6 degrees and 200. This time it's a little closer. Oh, and I hit it right off the bat. So I actually didn't plan that, but that's pretty good. If we wanted to try missing it, I could do 7 and 250, for example, and it's going to way overshoot. or I could try 5 and 40, and it's going to weigh undershoot. So that is my project, and I hope you enjoy playing the game, and thanks for the course.